Hello and welcome to my PWS presentation. I'm Daan Sluijs and I hope you can enjoy. Why we chose this topic? After doing short speed dates at the beginning of the PWS, we already knew that our subject had to do something with chemistry. After some searching on the internet, we thought it would be a nice idea to do something with water, in specific swimming pool water. Because Maureen is a swimmer, I thought it was a nice idea to use swimming pool water for a science project. If you look on the internet, you will find many studies about how much chlorine there is in swimming pool water. But that's all an average of all kinds of places in the pool. So we thought it would be a good idea not only to investigate how much chlorine there is in swimming pool water, but also whether the position and depth in the pool has an influence on the chlorine content. Learning from our previous slide, the main question is what influence does the place/depth inside of the swimming pool has on the chlorine content? Three sub-questions we had were: why is there chlorine in the swimming pool? What makes the pool pH neutral? More information about that later. And in what ways can you determine the concentration of chlorine? Wave testing. First, we needed to get monsters from the swimming pool. We used little containers to put monsters in, like these. Inside the swimming pool, we took a sample of each of the highlighted areas, highlighted over the star. There's a total of 12 stars. They're all different depths and different positions in the swimming pool. Then, outside the water, we added a little bit of potassium iodide, so the chlorine is locked inside of the water. At the school, we added a little bit of starch to each of the monsters. By adding the starch, the monsters we took from the swimming pool in combination with the potassium iodide will turn a blue/purple color normally. Because in the swimming pool the chloride reacts with the potassium iodide, one of the reaction products is iodine. Iodine reacts with starch and that creates a blue/purple color. But we found out that the concentration chlorine was too low to measure with our equipment. Because of the chlorine concentration being so low, there wasn't enough iodine created to be visible in combination with starch. But we did manage to get one of the monsters to color so that it would be usable for the reaction. We only have the chlorine concentration of that sample, which just isn't enough to compare it and have a good end conclusion. End results and answers to the main and sub-questions. As I said in the previous slide, we only managed to get the answer of only one sample. In the slide, you see the two tables, results, and the calculations. We ended up with a chlorine concentration of 0.000006 moles per liter. Now the answers to the main and sub-questions. Our first sub-question was: why is there chlorine in a swimming pool? The answer to that question is actually quite simple. The chlorine in a swimming pool works as a disinfectant so that the swimming pool stays clean. Sub-question 2 was: what makes the pool pH neutral? Let me first explain a little bit about pH. pH is the acid/base balance of a liquid. In a swimming pool, the chlorine that is added to the water is an acid. That means that if we didn't add a base liquid to the pool water, our skin will eventually irritate, which isn't good for our health. So they needed to add a base to the water to make the pH neutral. The base that is frequently being used in a swimming pool is a carbonate buffer. Sub-question 3 was: in what ways can you determine the concentration of chlorine? There are actually many ways to measure the chlorine concentration in swimming pool water. A few examples are a redox titration, a reaction with free chlorine, etc. Our answer to the main question is, unfortunately we only had the results of one reaction, because the other reactions were not measurable. That means that we can't give answers to the main question being, what influence does the place depth inside the swimming pool has on the chlorine concentration? What we do know is that the concentration in chlorine is so low that you need very precisely equipment that we don't have access to on our scoop. Reflection. After all, I found this an interesting and fun project to do. You learned all about research, like how to set it up properly and how to enter it properly. I also learned how to use Excel, like doing calculations, setting up tables, and finding specific data in a large data pool. I think our cooperation between me and Maureen went quite well. We both did our parts for the PWS, only she knew a little bit more about the project, about the subject, which meant that she needed to explain me almost half of it, because I didn't understand it. But after all, I think that the making of the PWS and researching and making the reactions went quite well. This was the end of my presentation. I hope you liked it, and maybe see you next time.